is the one of the definition. Okay, let us have another definitions also. For immiscible liquids, we say that are the liquids, or are the liquids, which don't mix, not mixing together, not mixing at all, due to strong repulsive force. Strong repulsive force existing between them. Okay, so let me explain a little bit what does it mean about these two definitions of immiscible liquid. We say immiscible liquids are the liquids which don't form uniform solution when they are mixed together. If you take liquid A in a beaker and liquid B in a beaker, and then we mix together in beaker C, what happens to these immiscible liquids? They will never mix it together. We have miscible and immiscible liquids in chemistry, right? So the miscible liquids are the liquids which actually mix it together and form a uniform solution, right? For example, in case that we have water and milk, so they mix together and then form a uniform solution. But the immiscible liquids now is vice versa. I mean, they don't mix together and they don't form the uniform solutions when they are mixed together. Or are the liquids which don't mix at all. They don't mix at all due to, why they don't mix it at all? Because there is a strong repulsive force existing between them. And this repulsive force, we are talking about repulsive force existing between the two liquids, or three liquids, or four immiscible liquids, means existing between the mixture of the two immiscible liquids. Okay? So then, again, so what happens? It means that because they don't mix it, these liquids, they form something between them, which called in chemistry separating layer. Okay? So we say that when two immiscible liquids are mixed together, then we form two layers, two separation layers. So we form two separation layers between them. So again, we have a new vocabulary, the two separation layers. So what is separation layer? That's the second question we have to answer in order for us to understand the concepts of immiscible liquid. What is separating layer? The question that you have. What is separating layer? Right? So you say that the separating layer is a layer, right? Is a layer formed between two immiscible liquids, okay? To separate them from mixing together. from mixing together. Okay? Mixing together. So he said that a separating layer, this is a very important layer in concepts of immiscible liquids, is a layer formed in between. This layer is formed in between two immiscible liquids to separate what? To separate them from mixing together. Remember from the definition we say that the two immiscible liquids or the miscible liquids, they don't mix at all, right? Why? Because there is a strong repulsive force. So because there is a strong repulsive force between solvent 1 and solvent 2, so what is going to happen is mean that because each of the solution, or each of the pure solvent is actually repulsive, it means providing repulsive force to another one, right? And then at the end of the day, you'll find that they form separating layer between them. Okay, so that's very important concept. And then when you know now the third key point for in this part of introduction, now let us go to examples of immiscible liquids. You know the definition, that what the meanings of immiscible liquid right now. Congratulations for that. And then again, you know the meanings of the separating layer which exists between the immiscible liquids. So I want just to tell you that you are approaching to understand the immiscible liquids for the rest of your life. So now let us see or learn examples of immiscible liquid. Okay, examples of immiscible liquid. Before I mention these examples of immiscible liquids, I would like to ask you if you have understood, because immiscible liquids are obvious, we have them in our domestic uses, right? Because if I mention them, I will mention the solutions or the solvents which are familiar, human beings is using since you are a child, you should until that age. So now I want just to ask you, if you've understood that these immiscible liquids, what the means of immiscible liquids, can you think about an example of immiscible liquids that you have ever met it, however that you didn't know the name? Yeah, I guess yes. So let me prove about your thinking. The first example of immiscible liquid is water and the kerosene. So you see, water and the kerosene. Water is domestic solvent. Kerosene is domestic solvent, right? Water is used for drinking, for different applications in domestic. Kerosene is used for lighting, for providing lighting, for cooking, and for different purposes. Okay, so if you mix water and kerosene, then they form immiscible liquids. So there's a layer that will be formed between them. So they don't form the uniform solution. Number two, the second example, I guess you are familiar with it because this is domestic solvent, water and the petrol. Okay? The solution, it means a second example of immiscible liquid is water and the petrol, right? Again, the third example, I guess we have water. Now, just we can go to a little bit in chemistry, okay? Dimethyl ether. So, it means immiscible liquid should be formed by water and dimethyl ether. And then in chemistry lab, again, you can find immiscible liquids between water and the benzene. Water and what? And benzene. And then the fifth example, it doesn't mean that it end is between water and the chlorobenzene. Water and what? Chlorobenzene. So, etc., etc. We have a lot of examples of immiscible liquids in chemistry and in real life. Okay? So now we know the examples of immiscible liquids. You can even think that's better for you to, before I put this with X, let me just leave it, okay? Find example number 6, example number 7, so fill the blanks, okay? At least you know 7 examples of immiscible liquids. And I believe that you enjoy, because the main goal on this channel and on teaching this stuff of advanced chemistry is to make sure that you like chemistry. So whether you dislike it, whether you hate it, I believe that I'll be convincing you day after day to restore your love of chemistry. Okay, so then that's all about the examples of 40 of examples of, but again, see, there's number 6. Let me help you for number 6, and then we'll look for number 7 and 8. So fill the blanks for number 7 and then number 8. Number 6 is water, the solution, also the mixture of water and the cooking oil. So cooking oil is common in kitchen, right? Then let us go to demonstration. Called the demonstration, or diagrams of immiscible liquids. Okay, diagram of immiscible liquids. We still a subtopic of introduction. Okay, immiscible liquid. Okay, immiscible liquids. Okay. Okay. So suppose that, or we say that the diagram below